Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff. We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are you ready? Debate fans, are you ready? For the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen, let's get ready to rumble!
Make sure your argument is tight. Baby, what? You must got proof if you so right. Baby, what? Don't get dismissed on false claims, cause you gotta bring the truths and the facts. It don't matter if you talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what the ism. Live on Debatism.
And welcome everybody to another night of Debatism. It is on to episode number X11. That is today, June 18th, 2024. We've got Roohif going against Shane St. Pierre. Curvature, is it optical or is it physical? We're going to give them each 1 minute intros, and then they're going to get into a 30-minute clock each, in which point they can... we didn't talk about how you're going to... We'll bring them on and we'll talk about it together, shall we? All right, let's go. We've got Roohif here on your left and Shane on your right. Let's start with Roohif. Roohif, say hello to everybody. They'd love to hear from you.
Yes, I'm sure they would. I'm already copying it in the chat. I'm going to do the usual, talk about how we can measure the Earth and it measures the globe. We'll do the usual Theodolite stuff. I might talk about LIGO. I might talk about physically measuring the distance between longitude lines. But yeah, the usual stuff. And I'll be refuting Shane's Rayleigh criterion rubbish at the end.
Sounds fantastic. All right, and Shane, say hello to everybody.
Nice. What's up? Good to be back, everyone. Good to see everyone. Also, thanks, Roohif. Probably some mutual respect here is going to be different to witness, I think. I think we're going to be able to have a good discussion and have some good back and forth without calling each other fuckwits the whole time. But there might be a little of that.
You might be wrong about that. We'll see. Let's start with the coin toss real quick. We'll let Roohif go first since he's in hostile territory, as they might say. Roohif, do you want modern day debate or do you want Debatism X?
Debatism X all the way.
That's the way to go. That's the way to go. All right, let's see what it is. We got, well predicted. You want to go first or second?
I think Shane really wants to talk about Rayleigh's criterion. Okay. So, yeah, Shane, go first.
Okay, so usually there's a buzzer, and then you guys can take over control twice, but I didn't give you guys the link. So could you have a piece of paper or something you could just wave at me if you want to take over control? Okay, and you each get 2 of those, so just wave something. Wave something at me, either your hand or get my attention. I'll be watching you guys looking for that signal. So we're going to put a minute on the clock. And Shane, he says you're going to go first. Sound good?
Sure.
Let me make sure I've got your minute on there. And we are good with the minute. Okay, good. I'll start that over for you. All right, whenever you're ready, I'll start the clock.
Good to go. So we're going to be arguing that curvature does exist in the optics format derivation only and is supported by optics math, optics angular resolution limits, Rayleigh criterion, and all sorts of corroborative sort of sites and corroborative evidence, including good old Eratosthenes would be supporting our optical Earth measurement. But the question is, right, have you ever seen Earth curve and angular resolution in the same frame at the same time? What if they're the same thing? It's like, yeah, so we all know there's an apparent drop proportionate to distance. Either the mainstream position is that it's caused by geometrical physical Earth curve. Counter position will be it's optical in nature, not due to physical Earth curve and due to the angular resolution limit and the loss of the horizon, loss of information due to the horizon, disappearing bottom up on a flat plane as it has to with the limit of optics. Pretty much it. 33.
Thank you, sir. All right, and Roohif, you got a minute. When you're ready, you go ahead.
Quick response. I'll share my screen. 1 sec.
Let me start it over.
Yeah. All right. Can I, am I screen shared?
You got it.
Cool. All right. So the Rayleigh criterion is a mathematical formula that determines the angular limit at which 2 point sources of light are resolvable. The formula is on the screen. So the angle theta is the angular separation of the points. Lambda is the wavelength of light, and d is the diameter of the circular aperture. Because what happens when light enters a circular aperture, it causes diffraction, and that causes what's called an Aries disk on the image sensor or whatever you're using. So on the right, you've got 2 point sources of light, the 2 green dots, which are separated by whatever angle. If they become too close, then they are no longer resolvable. So Rayleigh's criterion is about calculating when that point is. What's the angular separation when they become unresolvable? All right, and it's usually applied to things like, minutes up.
You went a little too fast, a little too slow. All right, so I guess, Shane, you're going to be starting off. You got a 30-minute clock, and whenever you start, we'll get going. And remember, just to get my attention, just wave me down.
Cool. Do you want me to stop sharing?
You don't have to unless he's sharing, but I think he just does it on his screen, so we'll see.
Yeah, no, I mean we can go through with this and just back. So we got like mostly back and forth now, right? Just time to speak, or
yeah. I mean, it's if I hear you guys just going back and forth kind of quick, then I just stop both clocks. But as long as one person's talking, then I'll just put the clock on for that one person. So it's meant so that there's not talking over each other. That's what it's meant for. I'm
not opposed to Roohif finishing this thing here. I think he's doing a pretty good job.
Cool. All right, I'll keep going.
Okay.
Yeah, so Rayleigh's criterion is usually applied to things like binary stars in astronomy, something where, well, hang on. Alan just tells me my audio is not very good.
What's wrong with
my audio? Okay.
Sounds good to me.
Okay, cool. All right, cool. Here, let me just check the microphone settings then. There we go. All right, is that better?
Actually, you sound a little better.
Yes, much better.
There we go.
You're a little loud now, but
all right. Yeah, so on screen is Eta Cassiopeia, and they've measured the angular separation between this binary star as 12 arc seconds. Now, if you are looking at this with the naked eye and you're doing it at nighttime, your pupil diameter might be about 6 millimeters. And if you plug all those things into the Rayleigh's criterion formula, you end up with an angle of resolution of 23 arc seconds. All right, because that 23 is greater than the actual separation of 12 arc seconds, you can't resolve it as 2 separate dots. Oops, but if you use a telescope with a much larger aperture and plug that into the formula, then your angular resolution is much greater. So you have a much higher resolution, and your Rayleigh's criterion limit is like less than an arc second. So you can easily resolve the 12 arc seconds between the 2 stars, right? That's what Rayleigh's criterion is. It has absolutely nothing to do with bottom-up obstruction. It has nothing to do with things disappearing at all. It's simply 2 lights merging into one, and that is literally it. It's just rubbish that this applies to Earth curvature at all. Back to you, Shane.
Yeah, see, that was solid. That was a good depiction of Rayleigh's criterion. It was also a great example of how to increase angular resolution, and bring it up would then bring things which have been unresolvable resolvable. That's a perfect example, and I definitely agree with that. However, we have this formula, right, derived from angular resolution limits and Rayleigh's criterion, which involves the optical, expected drop rate over a certain amount of distance and the supposed radius either of spherical Earth or the vision limit, right? And we have this formula, let's see here. Can I put it over here? Hey, here we go. Right? So we got R equals D over the tangent of theta, which is straight from basic angular resolution limits formulas, right?
The theta is what's coming from the angular resolution, not that formula.
You don't find any algebraic similarity between, say, basic optics reduced angular resolution formulas in this?
No, I'm saying the theta that you're putting into that formula is coming from Rayleigh's criterion, right? That's the result of Rayleigh's criterion. Yeah.
Yes. Yep. So we have, r equals radius slash of Earth or of spherical limit, and with d equals distance, and theta equals the angular resolution limit, which of course roughly 0.21 degrees ish if we do all that math.
Well, that math is important, so let's do that.
Oh, all right. Hold on.
Because 0.216 didn't come from nowhere, right?
No, it came from these specific parameters over here: red, orange wavelength, and diameter of a human eye with 6-foot observer on the surface with lots of abstraction. Red, orange wavelength, and I think a squinting pupil diameter. Hold on one sec. I got it here. Boom. So right there, right? You've seen that slide.
I have.
So Rayleigh's criterion over here, and of course visible light spectrum 666 easily equaling right in the middle for orange red right here, far away, and then focusing on distant objects as a diameter with a pupil would be 2.116 millimeters easy, and then you have theta in radians equals 1.22 times the wavelength over the diameter equals 666 over 2.16 equals conversion back to radian 0.216 degrees.
Cool. So if you plug in a different wavelength or a different pupil diameter, you get a different degree, right? A different angle. Rayleigh's criterion.
Hey, it turns out you can do all these pairings.
Yes.
For different wavelengths and diameters, and they will all still equal, roughly 0.21 degrees. But the whole point is covariant proportionate scaling as a ratio.
How about we plug in 550 and 4 millimeters? Can we do that?
I mean, I do have a spreadsheet that would allow, but you're going to try and change.
Spreadsheet, Shane. Come on, give me some credit.
A spreadsheet. I didn't say whose. I did tweak it a little bit, and it's also
everybody. Shane has my spreadsheet for Rayleigh's criterion.
Yeah, I do. But that's that's your formula right there, right? I've also tweaked it a little bit. So you want to change one of these values to what?
550 nanometers
and
4 millimeters diameter.
Yeah, but see,
are they possible values we could use in reality?
No. Why would you use them?
No?
I don't know what they represent.
Like we can have it is possible to have a pupil diameter of 4 millimeters and wavelength of 550, right?
Sure.
Okay. So we don't get 0.216 or whatever it is?
Well, no, you can change the parameters. So if you're starting Rayleigh's criterion and otherwise deviate, right? But that just gets you how close you're going to get back to that radius value, because we have the formula, right? Which means even completely absent Rayleigh's criterion as a value, right? We can just use, say, distance to the horizon, 3 miles, and radius of our supposed vision, 3959, to compute roughly an equivalence for 0.021 degrees, right? Angular resolution limit, roughly.
Right, but which of those 3 values you've got in the formula, which 2 of those are measurements in reality?
Measurements in reality. So angular resolution limit is not a measurement in reality. Distance to the horizon is not a measurement in reality.
I haven't seen any measurements of the distance to the horizon. I've seen things like Black Swan, where you've got a one oil platform at 6 miles and one at 10, and one's unobstructed and one is obstructed. Right, but I'm yet to see an actual measurement of the distance to horizon. It's either the distance is more than this or less than this.
I'm going to measure the distance to the horizon formula.
No, I want a measurement, not a calculation. So your thesis is that you've got 3 values, and if you know 2 of them, then you can work out the third. I completely agree with that. Yeah, but the 2 measurements, need to be based in reality.
Which part is not based in reality? You said the distance to the horizon is not based in reality?
Yeah. Show me a measurement of the distance to the horizon.
You don't know that, say based on your average observer height, 6 feet looking out, based on that radius of value, that would denote the approximate limit of where the horizon would stop, right?
Yeah, it's a calculation.
Yeah.
Yeah, not a measurement, it's calculation. I agree that's where it would be roughly, well, with incorporating refraction, but that's not a measurement. That's a calculation.
Well, it comports to, like, say, all these different rates, right? Because it's a parabolic drop rate. So technically, for each observer height, you could use a period pair of either one of these. When they say 8 inches per mile squared, it doesn't mean linearly in perpetuity. It means integrally stepped at this point and then parabolically scaled, right?
Right.
So
I actually can't see those numbers, by the way.
Oh,
Yeah.
Want a little bigger?
Probably broadcasting at fucking 360p or something, Shane.
oh, come on, bro.
Wouldn't put it past you.
That one is a shitty slide, though. That's what happened.
Yeah.
There. It's buried behind this stupid thing. So, like, but it's just a linear scale. Like, it says to convert to feet, you got 0.6667 ish, and then you do that times how many miles to get the actual supposed drop in feet, whether it be optical or physical. So for 7 miles, it's 0.6667 times 7 squared, right? Times
But there is a difference between optical and physical, right?
There is definitely a difference between optical and physical, and we're talking about an optical drop rate, right? So the rate at which things appear to disappear into the horizon bottom up.
Yeah, but that's not 8 inches per mile squared. So it's not 0.667. It's probably about 6/7 of it. That's why we use 7/6R, right? So it's probably 6.8 inches per mile squared, assuming typical conditions.
Right, but then all that comports back to the supposed circumference measurement, which we calculated the radius with, right? So it's all based on the radius.
But your input into this formula, distance to horizon, ignores refraction. You've just used 8 inches per mile squared when it should use something else, like 6.8 or 7 inches per mile squared.
Ignores refraction for distance to the horizon. Boy. So we're going to disagree that that's an accurate distance to the horizon based on input formula, right? So this is like 1.22 times the square root of the observer's height in feet, right? As a derivative of 8 inches per mile applied, right?
Yeah, 1.22 ignores refraction. If you incorporate standard refraction, it's about 1.32.
All right, so you're going to stand on refraction as disproving all of the corroborative evidence for a vision limit based on the radius of a circumference taken from the limits of my view? You're going to say refraction?
Yeah, my point is that all the inputs that you've put into these formulas and all those pairs of inputs that you put into the formulas have been completely contrived to get to the desired result. Like I said before, I mean, we can see we don't have to use 666 nanometers for light and 2.16 millimeters for your eyeball. That's an incredibly precise measurement, 2.16 millimeters, right? It sounds very much contrived to get to your desired result.
But see, if that was the case, and then we just ignored those proponents to calculate Rayleigh's criterion from the beginning, then how come we can use the other two to get an approximation of 0.21 degrees or whatever? Like it's irrelevant if we can just derive it based on the other two, because this is an actual mathematical relationship that works.
Oh yeah, that's a triangle, sure. Yeah.
So we have an optics limit, an angular resolution limit, right? And the radius of our visible spherical limit. So those are all optics based.
Right, but two of those numbers, so the radius of the Earth and the distance to the horizon, are not measurements. And the angular resolution, you've contrived it such that you get the results that you want. That's my basic rebuttal to all this. And you know that. We've talked about this a lot.
But you're saying that because they're not measurements, it doesn't work? Like, I didn't even know that we had to use measurements. We could use calculations for things. We use them all the time in globularity, right? The radius has always been a calculation. Matter of fact, no one's ever measured the radius, ever. It's only ever been calculated by measuring a circumference.
Right. From a measurement of the circumference. A measurement of the circumference and a measurement of Eratosthenes' fucking sticks in the ground, right? Measurements to calculate a third variable. Same as like the angular size formula, right? You've got the measured angular size and the measured distance. You can calculate its actual size. If you have any two of those three variables as measurements, you can calculate the third one, right? But you've got three things. So your radius in your world is not a measurement. The distance to the horizon, not a measurement either. No one has literally measured the distance to the horizon. You can measure the angle to it. You can infer an approximate distance based on landmarks. And your Rayleigh's criterion angle is just blatantly contrived to get the result.
But when you use your theodolite, right, and taking a measurement, are you calculating based on what? You're having a horizon?
Make a measurement. It's a measurement of the angle.
But then a measurement of what? Say if you measured, say, Eratosthenes, right? Let's go back to the beginning of all sphericity here. This is the one measurement that was the foundation for all of sphericity, right? This is definitely proving the globe right here. You're familiar with the specificity regarding Eratosthenes?
Don't use the word prove, Shane. You know I don't like the word prove. Don't use that.
Are you familiar with the specificity of the observations here?
Yeah, 7.2 degrees between Alexandria and Syene, and it was 800 Ks, something like that.
Right. So on equinox within Alexandria, a dude takes measurement of the shadow on his simultaneous observation from his partner dude in Syria, 800 kilometers away, takes the same measurement of the simultaneous, takes the measurement of the shadow, finds the difference between those two, 7.2 degrees, right? He does some math, thinks that's 1/50th of a circle, does an equation, 360 divided by that observation times the known distance, 360 degrees divided by 7.2 times 800 kilometers gives us that 40,000 kilometer circumference. But what you have to describe to me is how that would apply to the ground beneath your feet when you're measuring the shadow of the sun, looking at the shadow, applying it to the shadow, and you're deducing ground beneath my feet is curved. How does that work? How does it not more accurately apply to this, as circumference would be, of course, circular, not spherical? So then we would be left with, like, how would you apply this to sphericity first?
Right. So Eratosthenes only had 2 points. So it was the well where it was directly overhead, and then wherever it was, 800 Ks away. Didn't have to be simultaneous at all. I mean, it would be well known on this day the sun will be directly overhead, right? So just on that day, what's your local solar noon? What's the angle of the shadow? And you got 2 points, right? It is true that 2 points can point to a local sun, but there are 2 ways around that. Number one is just do 3 points, and then the 3 points do not meet at a single point if you assume the Earth's flat. They do meet at a single point if you assume the Earth is curved. Back in Eratosthenes' day, I know Ptolemy around 170 AD, I think. I know Ptolemy knew that the angular size of the sun didn't change. Therefore, it's far away. Therefore, the light's parallel. And therefore, you can get away with 2 points.
Well, funny story about that, actually. Eratosthenes, our boy, assuming that light was parallel, right, went to make the other measurement and said, well, actually, because of this and because light is definitely parallel, the whole galaxy is tilted at 23.4 degrees. And that's how the tilt comes from, because he was unable to say that it wasn't actually the assumption of perpendicular parallel sun rays that got him in trouble. It was, of course, let's tilt the whole world at the corresponding angle to make it make sense. But if we have over here 3 observations doesn't refute it. And I don't think you're grasping that the whole observation, the measurement that keeps getting corroborated, what Mattoon has in a spreadsheet, what gets over and over and over corroborated, why people keep saying, we keep reaffirming the measurement of sphericity. It's just this measurement of the limit of the sun, man. This is all it's ever been. It's always been, look, if I'm on this plane, right, and I see the sun angle, and we take this difference from the shadow and we assume that it's parallel and then only crepuscular in perspective, then I can always calculate based on 7.2 degrees or whatever the actual measurement is. We'll use 7.2 divided by 360 times whatever the distance is between these two, staying with the celestially projected geographic coordinate system known as the graticule and is inherently curved based on angles of the stars. Staying within all of that, right, we can still use this distance to get the limit of our spherical view, which always comes back to the math that we were just going over so clearly. So then we have a measurement of the sun backing our optics limit, which would be, say, the spherical limit of our vision here, right, using an arctan, right? That's why we can use arctan in our limit, because we're getting a lower limit of extremity.
Can you go back to that one with all the shadows on the flat Earth and the shadows on the alpha 1, alpha 2, alpha 3, alpha 4?
Yeah.
2 slides back, I think.
This one.
That one. Yeah, so bottom left, right, you got the flat Earth model. You got alpha, move your head. Move your head out of the way. Other way. There we go, right. So you got alpha 1, alpha 2, alpha 3, and you've got obviously the angles. And we know the distance from those sticks to the subsolar point, all right? Are you suggesting that those angles and distances work in reality?
What I'm suggesting, right, is that measurement will comport over and over and over again to say a measurement of the limits of his sun, right? Oh, wait a second. I got to put up this image because that's I forgot. It's not on my presentation. Actually, if you like put a pin in Alexandria and you map it out the limits of the sun to where he was. Actually, here, let me do this. Back up. Slide, put it in.
Thank you guys for your super chats. If you want to ask either of these guys a question, you can send those in, or Rokfin Tips. We'll get to them at the end.
There we go. That was quick. So what we have there, right, is literally, here's our measurer, right? Here's his corresponding thing over here. It doesn't matter. Here's the limit of the sun as it circles the Earth, and here's where he would see its limit rise and set to him, right? So look at the circumference.
What's the limit of the sun?
Oh yeah, this would be the limit of the sun, the limit of the light of the sun, the light distribution pattern on Earth, right? For this guy, it would be at this limit. You would see it over there and over there.
But is that 3959 miles?
It is.
Excellent. Okay, but what happens to light that is further away than 3959?
What happens to light that is further away?
Well, do you not see it, or what's the?
Well, so it becomes unresolvable, and that little blob curve between when two Rayleigh's disks becomes resolvable as one, and it approaches a limit in a logarithmic like until never approaching, right? So it doesn't actually become completely unresolvable, but it approaches that limit. That's what happens.
Okay, so if I can see the sun at just after sunrise and it's half a degree wide, how far away is the sun at sunrise and sunset over the ground?
Well, you're talking about arcs and chords, geodesics, and linear lines again. Yeah.
Let's assume flat. Assume flat.
Well,
how far away is it?
You're trying to comport a distance of a geodesic computed versus linear, right? And we have the Gleason's map as our Bible to straighten out those great meridians to become equivalent. So I think you're talking about this, right? Which would be, oh wait, no, it's not.
No, I'm saying that on a globe, every sunrise and every sunset, the sun is 6,200 miles away.
Oh, you see how
I can
this,
see it.
You see how this perfectly demonstrates that as the corresponding geodesic distance along the sphere of your limit versus the linear radius. Look at that.
Didn't you say the radius was 3959? How do you get 6210?
3959. This would be the spherical. So assuming this is a sphere, this would be the corresponding distance to this point at any point, right? On a sphere. Look at that.
Where are you getting 6210 as the arc length between your zenith and the subsolar point? How is that at all relevant?
Well, that is actually the what you get when you trig out from each latitude using a unit circle with a governing vision radius of 3959. Remember the person in the celestial sphere? Yeah, well, this is a spherical thing, right? Not a circle, right? This is a dude who sees in a sphere.
Yeah. But
so to get a
relevance
point on a sphere, you have to use geodesic, right? So that's why it's equivalent. And that's how you can see a sun of just about eking out of the limit of your vision, but still visible to you via, say, twilight and dusk.
That 6210, you're saying it from your zenith, 3959 miles up, to the point on the ground, 3959 away. That arc length is 6210. I agree. Completely irrelevant. Doesn't tell you how far away the sun is when it's on the horizon.
Well, if that's
if your limit is 3959,
right? You're saying that the furthest limit we can see the sun is 6210, right, on the sunrise, and that's where you're going to go with it, right?
Yeah. And your sphere has a radius of 3959. So how 6210 is bigger than that?
That's right. But as you know from the work we did before, right? Hold on, let me find that bad boy with the wonderful image of the arc comporting to the limit of the radius. Back when I was doing the celestial sphere work, and we had to figure out why 6210 wasn't the radius, because linearly straighten out that great meridian. 69 statute miles per degree times 90 degrees of separation yields 6210, giving you that linear, straight out comparable distance to the straight arc of radius, right? Or the straight line of radius. So what we have is the equivalent comparison of our straight radius of our limit, which is one line in all directions from the observer, and then the corresponding distance you have to compute to get an object on that limit, say, from under a GP of a star.
Oh, okay. That makes absolutely no sense.
Oh,
Anyway,
come on.
I've said my piece.
It made perfect sense.
Go on, Chair.
Celestial navigation, you're using a hemisphere. So if you have a thing above you that's spherical, then why would I not want to use an arc geodesic distance to reach that stellar object, right, in my sphere of vision? How would that not make sense? In fact, why would I be linear?
Yeah, the reason why that 60 nautical miles per degree is linear is because the Earth's a sphere. If it was flat, sorry to jump to a tangent of celestial navigation.
I'm ready. I got you.
Oh, do we have to? I want to get to my stuff shortly as well. Yeah, so that linear ratio of 60 nautical miles per degree away from the GP, it tells you the shape of the Earth. If it were flat, that relationship would be trigonometric.
Well, no, because that's assuming, supervision. Oh, look, hold on, let's go back. Better put Excel. Oh, look, we have Excel. How'd that happen?
Get your fucking head out of the way.
Oh, man, you know what? We could do that. So here's the actual Excel, right, from the thing that we built that uses the same
we built
trig.
this together.
We did. Yeah, you helped me. You didn't know. I don't think you knew what you were doing because you were so eager in the math, but yeah. So, right, actual height, 6210, computed by apparent angle, right? So we have this comparison that I keep showing everyone that you've definitely seen that made the rounds, right? Based on, where's my nice charts? There we go. This chart right here, right? Apparent angle to optic angle, essentially meaning that when we use optics to derive things from celestial navigation, it's not linear. It's more approaching logarithmic, and it has this limit. And this area right over here, which doesn't comport, which is exactly the area we're talking about, and why things become unresolvable, as you so nicely pointed out earlier with Rayleigh's criterion, will now support why this is an optics function, right? Optics right here, we can't quite resolve it. Right over here, the limit doesn't quite become unresolvable. It just becomes, between the limit and unresolvable, right over there.
Is it, where you got the red line at 75, is that the 15 degrees above the horizon?
No, so these are corrections. So when you're trying to celestially navigate, they allow you to use this portion of it mostly linearly. A part where it's linear, you can use it without corrections. And if you use after this, you have to use all these corrections based on these charts over here, right?
But which side of that graph is looking straight up?
Which side of my graph is looking straight up?
Yeah.
We got apparent angle.
Yep.
Apparent distance. Notice apparent distance is governed by 3959. That's because the function of our unit circle that we did was split that hypotenuse back to 3959 to accurately enforce a vision limit, right? This is why I'm going back to this, because the angles from the sun would work if you assume you don't see forever, because that's retarded. And then if you correctly apply, say, an actual limit to your vision, accounting for Rayleigh's criterion, angular resolution, light attenuation, then you get the exact measurements of 3959 around you, and then an actual spherical limit 6210. That's what this is. That's the actual derived maximum height that you will ever get using this formula all the way down.
All right, I think I've said my piece. It's rubbish. I've explained why. Do we want to move on?
Yeah. What else you got?
Cool. Should we do LIGO?
Are you going to comport curvature of LIGO, or are you going to talk gravitational wave interference?
Oh, no.
All right.
We'll do LIGO, the measurement of it. Give me a sec. Sharing screen. Where is it? Slide that one. All right. Am I sharing, Shane? Oh, Jaron, sorry.
Yes.
Cool. This is a complete ripoff of a dude that goes by Cinnamon Control on YouTube, Cinecon now, so Cinnacon. He made a video, I don't know, 4 or 5 years ago, where he downloaded some LiDAR data from LIGO Livingston in Louisiana, and using some GIS software, just got an elevation profile of the tube, and then showed that the elevation profile is curved. All right. So I've done the same here. I've got the 1 meter resolution data, drawn a little red line on it. And then you can see down the bottom that elevation profile is curved. And why is that important? Right. So I've graphed it in Excel, that same data, the LIGO point cloud LiDAR data, and used Excel. And I've translated them to inches and miles. So the elevation is in inches, and that's on the left. And the distance in miles is along the bottom, right? And then you can tell Excel to put a line of best fit, and the line of best fit in inches per mile squared on this data is 7.33 inches per mile squared, 7.34. So either LIGO, so the arm of LIGO is straight and sea level is curved, or B, the LIGO arm is curved upwards and we're on a flat Earth. Which one of those? They're your two options. I tend to go with them spending billions of dollars on building this thing and having an evacuated tube, telling us that it's straight and therefore the Earth is curved at, approximately 8 inches per mile squared, 7.34.
No, there's a paper actually. You wouldn't recommend that. It's a paper actually that supports the non-curvature of this. Actually, it's by Jones and Razimi and Weiss. It's called the precision alignment of LIGO 4K arm using the dual frequency differential global positioning system. Right, it's published in Review of Scientific Back from 2001. But what it says verbatim is that the beam tubes needed to be aligned along the propagation direction of light in vacuum and not along the direction perpendicular to local gravity on the surface of Earth. The alignment, therefore, was not the same as that for a level highway or pipeline. A second special consideration dictated by the nature of the construction project was that the GPS alignment needed to be carried out concurrently with the construction, with no significant opportunity for a check to be made by standard optical techniques until construction was completed. So, did they account for curvature? Absolutely not at all. People just say that online. Secondarily, what are you looking at here to get a topographical, let's see, what did we get? Did you look at Google Earth? What program were you in when you started?
Hang on one sec. Called QGIS, and you just import
QGIS, which is working as a projected coordinate system off which datum?
Oh, WGS84. Yeah,
so
the elevations.
The spherical datum that we started with, comporting with converging longitude lines and inherently spherical, right? So our spherical gradient.
Well, the elevations are what they are, right? You can go out and verify the elevations, regardless of the shape of the Earth. So you either accept the elevations or you don't.
Are we saying that the laser housing is curved in LIGO?
No,
because it has to be absolutely straight. It's a fucking laser. Yeah. Okay.
Yep.
So we're saying it's straight and level completely, except that it's curved. Is that the position?
It's straight. So the tube is straight. Like the second slide. So the second slide, this is the elevation profile. So every dot here is like a LiDAR point. All right. So there's a bit of variance and rubbish around. But if you get Excel to plot it, it fits pretty closely to 8 inches per mile squared. Right. On the assumption, well, not even an assumption, on the presumption that LIGO is actually straight, then that is telling you that the datum for the elevation is curved.
Yeah, the datum you're starting with is curved. That's from the gradicular coordinate system based on WGS84, which is based on angles to the dude. It all goes back to the curved radicule you're working with. First of all, pulling up QGIS is the actual survey software that they put in with projected datum, such as WGS84, all curved radicules. But elevations don't really matter. To put a trend line on an elevation change topographically on a thing that needs to be level seems counterproductive.
Yep.
It's level.
Say straight. Don't say level. It means different things.
No, level isn't curved. Don't go full retard. Come on,
Shane.
man.
Don't drop the R word with a hard R. Yeah,
are you scolding me for PC points, bro?
Yes.
Guys, Roohif doesn't give a shit about this. He's lying to you. He's not PC.
I have special needs children myself. I would never use that word. What I was going to say, yeah, you can get elevations. You can determine elevations regardless of the shape of the Earth. All right, so it comes down to whether you accept the elevations or not. And if
I accept QGIS as reality or not, is what you're saying.
No, these are the elevations of the land surrounding. Oh, sorry, this is the elevation of the tube. We could also get the elevations of the canal alongside.
Was it in reality or in QGIS?
Well, the digital elevation models imported into QGIS, but these are elevations. Do you doubt that these are the elevations above sea level? That's the question.
I've always maintained that if you start with a spherical coordinate system and you calculate within a spherical coordinate system, your results will comport to a spherical coordinate system. And if you assume a trend line based on topographical changes on a thing that is inherently level, using QGIS and a curved radicule as a background additive and resultant, then yeah, you're going to get this trend line. But does this prove in reality that it's curved? Absolutely not. The paper that the people who built it back in 2001 seemed to say, actually, we didn't account for it at all. And people on the internet just sort of say stuff, it seems. What's this? Differential leveling. All right.
The process of getting elevations, do you understand that does not care about the shape of the Earth?
I understand, yeah, that you can get an elevation. But then what do you do with those elevation measurements? You comport them to a model, you put them in a logbook, you comport your linear surveying to supposed geodesic surveying to formulate and add to the datum that is the QGIS background, or no?
The datum is WGS84, but it doesn't have to be. The question I want you to give like a yes or no answer to is, would these elevations be the same regardless of the shape of the Earth?
The elevation of the topography on the land be the same? Yeah, I think so.
Yeah, okay. That's all we need, right? Because then we've just got, back to LIGO. LIGO. Then we've got the graph. And if those elevations are correct, and I think unless you have a reason to throw out all elevations, you kind of have to accept that they are correct. They tell you the shape of the datum on which they're based on.
Well, the datum we started with is a spherical radicule, and that's what the WGS old school clock ellipsoid is. That's where it comes from. That is what datums are. But
throw the datum out. Assume they're on flat Earth.
You can't throw the datum out just because we said that the elevations would be the same in reality, and then we stick to our QGIS background mitigated spherical radicule. It doesn't mean that it's not going to interfere and make sure all resultants fit with the radicule.
The question is, are these elevations correct regardless of the datum? Could they be correct, or are they correct even if the Earth's flat? And I think you're saying yes.
There can't be anything regardless of a datum. A datum is everything, especially when my whole position is projected coordinate systems are everything, right? So when people say what a map project, it's not the globe, it's a projected coordinate system that is the geographic radicule that is inherently spherical. Right. That's the correct answer.
Are they correct relative to sea level, regardless of whether sea level is flat or curved?
Correct relative to sea level.
Yeah, regardless of whether that's curved or not.
Yeah, so sea level is always purported by using as a horizon and the differentiator as the bisecting great meridian of any spherical coordinate system. So when using like the
Shane, that was fucking gibberish. Say that again.
That wasn't gibberish, man. I forget.
Sea level. Sea level is just sea level.
The alt-az coordinate system, though, which is what you would use to make measurements, you're using the horizon as a bisector. But the alt-az coordinate system by itself, just so you know, is spherical because you have a bisecting great meridian. The requirement for a coordinate system that is spherical is a bisecting great meridian. So when you say you see in a hemisphere and you have a horizon, right, you've automatically created your spherical coordinate system to comport with other spherical coordinate systems. That's kind of how the celestial became the geographic to became the actual datum in the first place. But we're saying that within the datum, you're going to say the elevation angles which comport to the datum and are required by the datum prove the datum. And I disagree.
All right. So let's say I'm at the shore of New Orleans somewhere, right? And I do a differential leveling survey to get to LIGO and survey the height of the tube. Regardless, I don't have to use a spherical coordinate system. I don't have to use a flat Earth map. The way differential leveling works is that you'll get the correct elevations regardless. Do you agree?
Yeah, I'm not seeing anything wrong with this.
Hang on, see my screen.
Am I missing the trap? No. I mean, I'm not an expert on differential leveling yet, but this looks to be fine.
Yeah. So the elevations above sea level are correct regardless of whether you're using WGS84 or whether the Earth's flat. Those numbers on the screen for the elevation are correct.
Between the level is 80 meters above sea level. Yeah, that's how regular planar surveying works, right? They make corresponding datums by sight and keep going kind of all the way through. And they make a line. Yeah.
Yeah. Irrespective of the shape of the Earth. Yeah. Right. That's my point, is that those points of elevation are correct regardless of the shape of the Earth, but the graph of them forms a curve. If the datum was flat and the tube is straight, then the graph should be straight as well. But it's not. The graph is curved. If you've got a curved elevation profile for a straight thing, if you imagine straightening that curve out, you're curving the datum. This is why LIGO, like I said before, I tend not to use the word proof, but this is the closest to a proof that you'll get, I reckon.
I mean, yeah, you're proving that the coordinate system and the datum which you started with is inherently spherical. That's what you're proving. How are you proving anything else?
The elevations
yeah, of real life topography. When comported into this model, which is a spherical model.
No, we've just got the elevations. We've differentially leveled from the ocean to here. Irrespective of
the datum is spherical, right?
No,
because we got here. Let's
these elevations do not care about the shape of the Earth. You can get them either way if the Earth is flat or if it's curved, because of differential leveling.
But you see this geodetic datum site right here, the NAD 27, NAD 83. Just look at it, right? And WGS 84, commonly the most used one. These are all spherical geographic radicules. So any calculations therein, within, about, will always yield the corresponding spherical differences, right? So again, here we have, but we're using this right here. We're comparing two datums, and what are they comparing? The flattening, inverse flattening, and curvature, right? Isn't that
right? But I'm not.
The datums are within the spherical coordinate system. So you're saying that over here, if I take these measurements, but I'm within this datum and I have to adhere to this datum, and I have an offset from a measurement that I use to calculate and fill in based on this datum, the datum has nothing to do with my calculations, and that's retarded.
We're not calculating. We're measuring irrespective of datum. The datum is just sea level. We can differentially level to LIGO, right, and not care whether the Earth is curved or flat.
Differentially level to LIGO, to the not curved portion, to get the topography based on a slight line and based on difference to elevation to sea level, purportedly, linearly, over and over again. You're saying that when I add those measurements and put them back in my spherical model, it proves a sphere?
The point of this is that getting elevations, you can get elevations by differentially leveling without regard to the shape of the surface. That's the whole point.
I don't think I'm disagreeing with that. I'm saying, what are you going to do with these elevations once you have them?
Plot them on the graph.
Put them where, though? You're going to use them with a. Is it going to compare to long lat? Is it going to go to a model? Is it going to add to the geographic?
I don't care about long lat.
If you're going to take these elevation differentials, what do you do with them exactly?
Yeah, I graph them to show that they form a curve. If the Earth was flat and LIGO was straight, that graph would be a straight line. And
you're seeing the basic components based on QGIS, which is what, fed from Google Earth based on a spherical radicule, right? So the layout of the original thing that you're measuring is going to be laid out such so according to long lat on a spherical radicule. Are you following?
But that's the question. Are those elevations correct, regardless of datum? Regardless whether the datum's curved or flat?
Let's say they're correct according to the geographic radical, sure. Long lat, the maps that we always measure, the distances that we can comport. Yeah.
You seem to be not answering the question. Are they correct regardless of the shape of the datum? Like, would you get the same elevations if you assumed the Earth was flat? The answer is yes.
If you just took elevations with differential leveling, and then I took elevation with differential leveling, they'd be identical.
Right. But would they be the same if we were on a globe compared to a flat Earth? Would they be the same?
No.
Yes. Yes, they would. Yes, they would. Looks like we have to talk about differential leveling.
Well, all you're doing is adding them to your globe via coordinates, mathematical models, QGIS interface in the background. So without that, they'd be the same.
Irrespective of the shape, the elevations will be the same. And this is why.
Differential leveling. This is a nice Roohif infographic I'll have to add to my collection after this.
Meme, Shane.
It's not a meme. It's not a meme. So, dude, this is just taking repeated measurements of leveling of topography.
Yes.
Right? And then how does that prove sphericity again when you're graphing them?
This is to show that you get the same elevation regardless of Earth shape. You could do this on a flat Earth. You could do it on a globe.
Topography and elevation isn't, I mean, it's not exclusively, right? That's why we say, elevation. Dude, you would make Bev go crazy to say it's flat. It's not flat, of course. We have topography.
Of course. Okay. The elevation of the topography relative to sea level. regardless of whether sea level datum is curved or flat.
No, you only get curved if your datum is curved, man.
No, the elevation doesn't change. This process, right?
It does, right? Because when you're graphing them, right, you're basing a position geographically on a coordinate system that is derived from a graticule that is spherical. So you're saying the layout of the thing that I'm beginning to measure, right? You with me?
No, because it's wrong.
No. So how is it wrong?
Right, you set up at the shore of Lake Pontchartrain or wherever your sea level is. You just leapfrog. So in this diagram, right, let's say A is actually at sea level. You set up your instrument somewhere, point back to A, get a measurement off the rod there, go and stick the rod over at point B, and get a measurement on the rod there. Right, the difference in those two measurements on the rod is the change in elevation between A and B. All right, that difference is the same regardless of whether the Earth is flat or curved. Because if you're in the middle, then the amount of curvature, theoretically, on each side is the same. So it cancels out.
Yeah. So the only problem then comes when you take A and B and try to put them in a map or a coordinate system or a grid or a QGIS background or to do any sort of data manipulation with them, right? Because then we're adding... Yeah, then we're going back to our coordinate system.
I keep going back to, are these elevations correct or not?
They would be the same, right? They're independent of shape, for sure.
That's all we need.
No,
if the elevations
you're
are
going to
correct,
apply them back to your spherical datum and go, look, behold, sphericity.
If the elevations are correct, regardless of what the shape of the datum is, then graphing them, right, for a theoretically straight tube tells you the shape of the datum.
No, it tells you the shape of the coordinate system, which is the datum, right? So if your projected coordinate system is based on a datum, wouldn't you think your results would comport with that datum?
The datum doesn't have to be WGS84.
It could be any other spherical ellipsoidal model.
It could be flat.
Sure. No, there is no flat datum, Roohif. There is no allowed coordinate system projection that is not spherical.
I don't know how many times I'm going to say it. We get the same elevations if we assume flat because of differential leveling.
Yes. No, elevations themselves
can be done
are not
on a flat
the problem.
datum.
Right? Differential leveling itself, I don't think is the problem. I think that topography by itself would be the same either way. It's what we do with these measurements and how we're, say, graphing them.
Yeah, these are the elevations. I've graphed them.
Based on what's on the left?
We agree. We agree that these elevations are the same regardless of the shape of the Earth.
Yes, elevations and topography based on differential leveling would be the same regardless of the shape. It's how you record and what you calculate and what you do and apply with these measurements.
Right. So how do you explain that graph on a flat Earth?
Well, if you were to not use your curved datum, it wouldn't be like that. Man.
I'm not using any datum, right? These are the elevations based on any datum. Sea level doesn't have to be curved or flat.
Is there no distance between these points?
Yes, there is. Yeah.
How is the distance calculated and compared to?
It's a good question. You could
Well,
run a little trundle wheel like I did yesterday.
No, I'll tell you right now, what we have there is the geographic geodesic distance between 2 points on a sphere. And that's why we have the resultant curvature. See?
No. Do you think that,
I thought I had.
that distance? Do you think that distance is wrong? Like if you were to run a measuring wheel along it, do you think you get a different result?
I think that there's no way to know. Yeah, we don't have a measuring wheel. All we have is a spherical coordinate system based on angles to the stars to compare measurements within a spherical coordinate system based on angles to the stars.
So, we can't measure the distance.
But you're saying that these measurements, right? So you have left, you have height, elevation, and I assume the X I can't see is distance. I can't see that bottom. All right. So what you have there is distance. When I said that the thing that you're measuring is mapped out and spaced out according to the distances within your spherical geographic graticule, what I mean is that the distances that we're comparing it to begin with to produce this curve is based on the starting datum, which is a curved graticule. Are you following me? That these distances are not pulled from a flat plane map. They're pulled from a sphere.
Right. But do you think they're going to be wrong? Do you think those distances are going to be wrong?
That's a different argument than what we were just going over, right? So you're starting with sphericity, you're concluding sphericity. You see that now, right?
No. Is the distance, on the first slide, QGIS, the data only covers about 3.7. I'll bring it up one sec. That one. Yeah. So once I cross this thing here, Yeah, I don't know how to merge the layers yet, but this is about 3.7 kilometers. I mean, do you?
Props for using QGIS.
Cool. Are you disputing that distance? Like, if we walked along with a trundle wheel, would we get 4 kilometers?
I know that distance is based on the geodesic, right? Over a short distance, a chord and an arc would be almost identical, different. Right. So, like, would it be accurate? Probably. That's why the distances for a geographic curved reticule are corroborated over and over again, because they're consistent. Are they right?
So
couldn't tell you, but I know they're
dispute
consistent. Then? Well, you're trying to say that this proves that the Earth is curved, and I'm showing you that your starting coordinate system, which induces and requires sphericity, is actually what's curving your resultant line here, because the distances, as we've gone over here, which are not based on optics and linears, the distances within QGIS are based on your spherical gradical coordinate system, for sure, 100%.
The datum, the fact that, well, I don't want to say the fact we're on a globe, the datum that is used for these points is not what's introducing the curvature, because we get the same elevations regardless of the datum.
Well, you see, now you're confusing the elevation difference, which, again, topography is the same unanimously between us no matter what. It's the application of that, like I said in the beginning, that will
is the audience bored?
Maybe.
Probably.
But I do feel like that I have made the point that you're starting in the coordinate system. I think that you kind of realize that the distances are based on the spherical graticule, so that we were concluding sphericity, that it would also, not be correct. But
the distance calculation probably, but we agree it's not going to be wrong. So I don't see the point.
I mean, like, we don't live on a map, right? But the maps that we're allowed to use are projecting a curved reticule known as the geographic coordinate system based on angles to the stars on the celestial sphere.
Okay.
You anyway. Cool with that?
I'll make my final point on it. These elevations are correct regardless of whether they are on WGS 84 or some flat Earth. They are just elevations above sea level. Given the assumption or presumption that LIGO is straight, this tells you that the datum on which sea level is based on is curved. That'll do for me on that one.
Dude, I agree that the datum that your sea level is based on is curved because it's based on the geographic spherical graticule, right? But just to be clear, we started with LIGO. LIGO didn't use differential leveling methods to determine the curvature of the thing. They actually did not use any methods to the curvature, as I cited in the paper, which I can put in the chat for everyone. They literally said we didn't do any method whatsoever. It was too fast. It caught up as we were building it, and definitely don't worry about it. People on the internet will say it's spherical. And we did conclude that when you're measuring distances within a curved spherical graticule, that you start with the curved graticule, you end with the curved graticule, no matter what, the distances will always comport to that. I agree.
All right. Anyway, next.
What else you got?
Oh, it's on me, is it? I was going to do Canigoo, wasn't I? Hold on. Canigoo.
Hold on. How about you bring up some theodolite measurements so I can scoop them up as evidence for my optics-based curvature?
You've got my video, right? My video where I measured the TV tower in Sydney.
Yeah, but you understand now that I'll be scooping up aggressively all theodolite measurements, and I'm coming for Jesse next. Where are you, Jesse?
Sure. Please take my theodolite measurements.
They will now support my method in my position soundingly, right?
Okay. Well, when you can make a prediction for what that angle should... Oh, that's the meme I'm going to bring up. Hold on. Hang on.
Wouldn't you know that I thought you might bring this up and made a spreadsheet as well?
Nice. All right. So I would like to see your prediction for flat Earth and basically show me the geometry of the prediction.
Well, I mean, like my prediction would just be this accepted prediction, right? Because I'm scooping up what is known as, you're saying physical Earth curve is now going to be optics. So the same observation and phenomenon will work with my now new framework because it has substantial mathematical backing and other outside corroboration, right? Beautiful.
So yeah, this is Rayleigh criterion stuff, right?
Yeah, scooped up by that. But
okay.
Even if we just use regular hypotenuse adjacent things for getting, say, input a theta angle, input a size, get a distance. Is that what you're trying to do?
Yeah. So nothing to do with horizon or bottom up obstruction. I love you ask and receive in the chat. Roohif has been boring us for years now. What a trooper.
I saw that too.
Sure, this is true. So
I didn't say
love you too, Tony Coriolis.
You see that? There we go. So right there. So if we input an angle,
Hang on.
right, we're using this basic function to just get a distance. Is this what you're saying we can't do?
I've got to stop sharing to see your screen.
Oh,
There we go. Well, the question is, what is the opposite side you put in? Yeah. Do you adjust out 8 inches per mile squared in refraction or not?
Why would you do that? This is an optics measurement. Like, this is more comporting to say along these lines when we're saying this is what we're doing optically. Oh crap, that's the wrong one. We're not showing. It's okay. What's this? Change. Gotcha. I see that's in the back, right? So this is more comporting with this when you're saying optically. I'm taking a measurement to my Theodolite of an angle with the sextant, and I'm applying that to get a distance, and then I'm going to use that based on the correction that I'm going to apply, which also has a logarithmic scale accordingly, of course, and then proportionate inversely logarithmic scale, and then we're going to get that angle to get the real distance. So this is back to this, this chart.
But my question before was, with that graph, is 90 degrees looking straight up or straight out?
Straight up.
So say it again.
Straight out, right on the horizon.
Out. Okay, yeah. So the left is looking up, 0 degrees.
Yeah, it's a 1/4 sphere, right?
So can you move your head out of the way again? Oh, that's reasonably straight. I'll give you that one. All right. Where were we?
Was that a concession you want to buzz by, or did you want to for the audience?
Oh no, I was going to say if you seem to be ignoring low sights, so the what is it, 75 degrees, so 15 degrees. You're saying it's because it doesn't fit your log function. I'm saying it's because of refraction, which can be incorporated and is a known effect.
But like, so if you were to use just optics and a sextant angle on the low degree, say 0 to 5, or on the high degree, say 85 to 90, when it's right above you or right on the horizon, what you actually get is not resultant linearity. What you do get is basic aberrations, right? Say right on the horizon at 90, if you were to take a sextant angle and calculate, you're not going to get 67 miles per degree. And if you don't get 69.07 miles per degree, if you don't get that every time, then linear is not. It can't be partially linear. What we call that is nonlinear. And nonlinear would be this logarithmic like scale, which is what I'm saying is actuality.
It is linear after you account for refraction, dip angle, that stuff.
Right. It's linear if you go here, you apply these corrections. That's exactly correct. I agree. But in that world, you never know is what you're using is not a linear function.
Right. But we understand refraction and must apply a correction for it. We understand dip correction and must apply a correction for it. When you account for those, it is linear. Oh, actually, technically not linear, because you got geodetic latitude versus yeah.
So like
the more blatantness.
Yeah, well, the closer to the horizon I get, the higher the correction. Almost the exact inverse of this graph, which is mirroring our favorite atmospheric refraction. Right. This is how
that's dip correction. You got there. Dip correction on the right.
Yeah. It is definitely to zenith angle, right? But this is the corresponding fix to if you want to use this logarithm, right? You see how those are nice fitting. That's what Witsit would call a conjugate geometric expression, right? We have these things inversely.
Witsit says a lot of stupid shit. So.
Oh, come on. You know that was brilliant. Conjugate geometric expression of the... I forgot about you and Witsit. That's right. I said Witsit. That's my bad. Yeah. So right here is exactly the explain for the correction. So if you're going to use a nonlinear function, then you correct it nonlinearly, I guess is what I'm saying. So that also comports with 69 miles per degree on a flat plane, which again is back to our original argument, which is the spherical limit of our view, this vision radius.
Oh, which is rubbish. Do we want to do Canada?
No, I don't want to. Can't do it.
Okay. What's the time, Jaron?
You want to do super chat and stuff?
3.5 minutes for Shane and 7.5 for you.
Okay.
Pretty good.
I would like you to predict. So my slide where I'll share it again. One sec. Someone asked in the chat, what did you make of the Professor Dave debate?
Yeah, Roohif, what do you make?
Yeah, Professor Dave, overly aggressive, interrupting, quite rude. In terms of the substance, I didn't like the way he approached the C2 fire observations. it took something like 10 minutes before he said the word refraction. And I'm sitting there screaming at the screen. Witset's bringing up this Pic Gaspard, 443 kilometers, saying, oh, there should be 16,000 feet hidden. And Dave's going, oh, you're probably lying about the measurements. And I'm like, no, they sound roughly correct, but he's just ignoring refraction. And during MC Toon's analyses of debates, he always brings up that clip of Witset saying, oh, refraction is one of the most important things you could ever, you always have to account for refraction. So I found that funny, yeah. Witset being a contradictory person.
You mean you saw that and you still felt bad for Witset? That's how big of a dick Dave. That's what you meant to say, right?
Yes. Dave didn't do well on the C2 far. And I didn't like his attitude towards the whole thing.
He didn't actually have any arguments. He didn't even make any arguments. He just said, I don't have to make my position is so strong, I can make zero arguments. All of the sky tells us for thousands of years. I haven't
finished it, by the way. I've seen his, two rotational poles is a great argument. But yeah, I haven't watched a whole lot of the thing. So Mike Jones, my little buddy in the chat, for $50, hey Roohif, what's the maximum correction for refraction if the standard correction is 16.7%? I think Shane has seen my refraction lecture probably 20 times.
7/6R pulled from which airport we want to get. Pick a 3-letter word. We're going to get the data. We're going to send the balloon up. We're going to look down from 100 meters. We're going to be...
Yeah. So basically the typical atmosphere has a typical gradient. And if you convert that gradient into a radius multiplier, you get 16.7%. As I've explained to Jeran, did I send you that document, Jeran, the other day, like a week ago?
Which one?
I did. About refraction. So why we use 7/6R.
Yeah, why you get up high? Oh, I thought you meant the one where we should get up higher.
We should get what?
We should get up higher.
That's that one, yes. Yeah. Why we need to get above the surface? Because when you're close to the surface, the refraction is not, the gradient's not typical. So in answer to Mike Jones' question, you can have occasions, what's the word I'm looking for? But you can have conditions. Yeah, you can have conditions where the refractive gradient implies that the light is curving greater than the curvature of the Earth, and therefore would appear flat. Measurable conditions.
And when we get up higher, we still have to use the regular refraction, though. Standard.
Yes, 7/6R-ish. Yep. Doing some more super chats.
Oh, you ready to do this? If we're ready to do this. Okay, good. We'll just go ahead and...
Unless you want to do Kanagu.
No, but let me bash on refraction real quick. When you're invoking refraction, dude, the coefficient, they commonly defined as K, right? Back from Gauss, when he defined it as the coefficient 0.13, coefficient K, which is based on a mean radius and average refraction for a circular path of light. So we're saying it follows the Earth's curvature. So by the definition of refraction, we're invoking the radius in the formula K equals R, big R.
In the K formula, yes. Yeah.
Just saying.
It's 0.14 now, actually. Oh, hang on.
Is it?
I think so. I'm trying to, what's his name? Larry Scott.
It's been the same since 39, and now it's all of a sudden they're going to change, I wonder.
39 gradient?
I mean, when's the last time they changed it? It's been 0.13 forever.
Yeah, since before I was born. About 0.14. When you said 39, do you mean the radio gradient?
Since 1939 is what I was saying.
Oh, okay. Sorry. All right. So the gradient, a change in refractive index per kilometer of a tiny amount, like minus 0.0000224 or something. That's typical. Mike Jones, my little buddy. What else did you say?
I got the first one from Blake. Blake, thank you very much. He said, I don't know what that is about. Pick a number 5 through 50. I have no idea what that's talking about. But thank you very much for that. And the next one we got is LJ. Why space travel keeps getting delayed for decades now? From LJ. I guess that's probably to you.
You don't believe in NASA, do you? Oh, come on.
Space travel's hard. They keep over-promising and under-delivering. Yeah, I agree.
But Roohif, if I can be in space from here
Yeah.
Right? Is space travel that hard though?
Seems like it's just math, really.
If I could use some math that'll put me, say, in an astronaut dancing in space, is that really hard though? Is it like
I think the engineering aspect is hard. Yeah.
Okay, we've got Blake, 1991. Thank you very much. $50, so 50 Canadian.
Hey.
I hate dishonesty.
Where's my cut, Jaron?
We'll talk about it after. I hate dishonesty. Refraction, like F off. Use your head.
Okay. Thanks, champ.
No comment on that.
Oh, fuck. That we can measure it is the answer.
How could you measure it?
Yeah, in that document I sent you, they basically send up weather balloons, thousands of locations around the Earth every day, twice a day. They measure the temperature, pressure, and humidity all the way up. That data is freely available. There are formulas to convert that data into a refractive index. So you have this data where at each point where it takes a sample on the way up, you have the refractive index, and you can then calculate the vertical gradient and then apply that to curve calculators or surveying or whatever you need to do.
Okay. So when I'm looking at San Clemente, why is it important for me to get the temperature gradient of where I'm standing if that's literally 1/1 billionth of the space between me and the mountain, between me and the island?
It gives you an idea. I mean, unless you're willing to sort of put out boats every couple of miles to measure the gradient out there,
No.
I mean, it's better than having no data.
Okay. We've got, at what size does the ocean and sea water start to curve?
1 plank length away from you.
Thank you. One plank length?
Yes. It's curvature. Like
Okay.
it's not made up of flat sections.
Okay. Unverified Jaren, regarding the final experiment, you said you couldn't see how the sun can go behind you, works on a flat Earth. Is there any way I can suggest a flat Earth model to where I can guarantee you see it? Twitter? Oh, you already read this one. Telegram's free. Get on Telegram and just send it to me there, or somehow get a hold of me.
And heckle
because-
Jaron.
Yeah, heckle me. I'd love to see that. I have not ever seen one yet, but it could be possible. I just wouldn't know yet. All right, Mike Jones, thank you very much. $50. Mike Jones, I just unblocked you. Thank you. I'm so happy I did. He says, "Hey Roohif, what's the maximum correction for refraction if the standard correction is 16.7?" Oh, you answered that, huh?
Yeah, that. Yep.
Well, which
You've
was
got another one there. How much, little buddy? Give me a value for the maximum: 20%, 30%, 50%, 100%, infinity. In terms of radius multiplier, if my little buddy knew geometry, as the gradient approaches negative 0.00157, the effective radius approaches infinity. As it passes through that 157 mark, it goes to negative infinity. Is your brain exploding now, Mikey, because you didn't get it?
Wait, are you saying you'll invoke a fraction of the sphere of infinite radius should you have to, and you're at Earth's surface?
Well, yeah, measurably it does. Measurably the gradient.
I think that's what he wanted you to say out loud.
No, he wants me to say infinite refraction, and I keep correcting people to say no, infinite radius. And an infinite radius is a
I
flat
got you.
plane.
I said it right, man.
Yeah, Mike will get there one day. Thanks,
Roohif,
little buddy.
stop dodging.
What was the question?
That's from Mike. He says, "Stop dodging."
Stop dodging.
Jesus.
What's the highest that I've seen? I've seen greater than the curvature of the Earth, which means it appears concave. So, yeah.
Mathematically, in fraction speaking, it's concave.
No, measurably.
Okay.
Measured gradient, which is greater than the curvature of the Earth.
Okay, let me check.
Yes, I did, Mikey, little buddy. Roohif just invoked infinite radius. Yes, I did.
Yeah, I made him say it.
Yeah, people that understand mathematics know that an infinite radius is a flat plane. So it approaches an infinite radius when you get to that specific point. And as you go through that point, comes negative infinity. What the hell?
So how much, I mean, are we very far off from having to be able to see our own ass? Are we close to that?
Technically, right? So like I said, the gradient can bend at the same rate as curvature of the Earth, right? So if you had a telescope that could resolve your ass from 40,000 kilometers and there was no light attenuation from scattering, then yes, theoretically. Obviously not in practice though.
Right. Because atmosphere or whatever.
Yeah.
All right. Anybody else? Let me check Rokfin real quick. And I know you got somewhere you got to be. So you say? No, nobody there. That's nice. Okay. Thank you, Robert Hunt. Very kind of you over there. Just wishing for a plane crash for me in Austin. It's nice.
All right. Angle of elevation.
That's the dude that wants to debate me on eclipses. So that's
that is him. Oh, that's the guy. Yeah, you're right.
Overly aggressive.
Considering he's the only one in the chat over here just going off and saying, I'm waiting for that plane carrying Jaron and Austin to spiral down into the airfield at Union Glacier. So that's really nice.
And we should go to a movie together and just like hang out and be friends.
Yeah, you guys will probably
kind of person. Yeah.
It's very friendly.
He says that he's best friends with Fred Espenach, so that's
really nice. He retired. Angle of elevation, $10 Canadian says, when will globies learn? Refraction is only at the point. If it's your perception over distance, it's not refraction. Your perception never caused refraction ever.
I have no idea how to respond to that.
Okay. Read it one more time.
Perception never causes.
When will globies learn? Refraction is only at the point. If it's your perception over distance, it's not refraction. Your perception never causes refraction ever.
Okay. I think I'll just say our atmosphere has a density gradient. Light bends through a density gradient. Spend another $10 to clarify, Angle.
Okay. But if light is traveling through just air, consistent air, then there is no refraction.
Right. If it's all the same density, yes. Yeah.
Dude, I did like how you started reading out Jaren super chats immediately, like they were all for you. You were so excited.
Oh, well,
helping Jaren right away. He was like,
unless you want to fucking do Katagoo, like
no. I just mean like you were so helpful to Jaren with this.
Thank you very much. I could have taken a nap for the whole second half of the show.
Right. Yeah.
Mike Jones says game over. $2.
Okay.
Thank you very much, Mike.
Thanks, Mike. Yep.
All right. Well, I can't think of anything else I have for you. Do you guys want to do a little outro, or are you good? You want to do a minute each?
Sure.
Sum up your position. All right, Shane, go first.
Sure. So again, we started with the observation with Eratosthenes proving not a sphere, but the limits of the sun, applying what you see as a measurement of the sun to the sun in the sun's limit, giving you the optical vision radius, which we then substantiated with math, angular resolution limit, all sorts of optical drop rates, including distance to the horizon formula with, 1.22 times the curve of the observer height in feet, all derived backwards to get 3959. And if you let us choose the variables of Rayleigh's criterion, then we will derive it to like a third or fourth decimal place, which is an alarming coincidence if not related and if sphericity is not optical. That's it. Oh, also, thanks Roohif for having a nice, respectful exchange. This is always awesome.
Love you, Pumpkin. Sorry. I was going to say,
I don't remember.
Yeah, basically what I said before. Those numbers to derive the radius in Shane's presentation are contrived to give you the result that he desires. You can see that by the, inexplicably precise numbers he chose, like 2.16 millimeters for the pupil, 666 for the wavelength of light. We can have different size pupils, different wavelength of light, and then we'll end up with a different diffraction limit. What else? Mike Jones, it was fun owning you tonight, Roohif. Thanks for confirming that if someone could sight something 10,000 miles away, you'd still say 'tis globe. Stars are more than 10,000 miles away, Mikey. All right.
All right. Thank you guys very much. Appreciate you being here for the show. And if you want to debate, it's best to find your opponent and then reach out. You can go to t.me/debatism or email debatism@outlook.com. And we will get back to you. Any final words, you guys?
No, thanks, Jaren, for hosting and being, even if I had an opponent who was super hostile, who I didn't want to deal with, I would bring him here anyway, because you're a super moderator who would, fairly be able to interject and allow that discourse to take place. Didn't need so much with Roohif, but for the record, you're the best moderator of those.
Nice. I thought it was the best part.
You are
thank you, Jaren. You are a good moderator when
you guys are nice to each other, it's easy.
Oh, yeah. Shane and I have been friends for a while, so even though he's completely wrong about everything
since I started as Flat Earth, dude, I approached him and had him teach me celestial math way back when. That's the story.
Cool. Huge Ass is asking Jaren, will you share a tent with Austin?
What does that mean? As opposed to not? I think
I'd
prefer Austin over Dave McKeegan. So I think I would choose Austin. If I had to choose, I'm going to take Austin.
What about if you and Professor Dave went?
Oh, God. It would not happen. Not going to happen.
I think Dave McKeegan would be fine. Yeah.
You'd have a beer with that guy, man, honestly?
No.
Dave McKeegan, yeah.
Oh, I thought you meant...
No, you wouldn't. Oh, I thought you meant... No, sorry. I thought
you meant Professor Dave. I could not even stand to be in the same room as that guy.
Yeah,
I'm sure he's different in person, but he was overly combative, I think, in the debate.
Are you? Do you think he's different in text? Do you think he leads every text with an add-on? Do you think he can help himself?
I have no idea. I haven't spoken to him.
I've seen some messages to Austin. He definitely is the same person in text.
Okay. Yeah. Okay.
What are you going to do?
Less I say, the better then.
All right, guys. See, I do have a couple of videos tomorrow, and look for that. And then Friday, we got the Jeranism show. I believe that is it. You have anything coming up, Shane? I know you guys both got to go, so.
We have, we've got Ben's presentation next Tuesday for the Hildegard Ether Wind, and then we got all sorts of presentations coming out, Ether Cards every Tuesday, and we got our usual Twitter thing on Thursday until Flat Earth Friday return.
Do we have a date of that? Do we know when that's coming back?
Flat Earth Friday return? We do not. We are waiting with bated breath.
Okay. Anything, Roohif, for
I've got a upcoming discussion with Jaren about refraction and San Clemente.
No, about Southern Flights. Wake up.
Oh, Southern Flights. Sorry. Yes.
You got it wrong. You got it wrong. Southern Flights. I can't wait for that. It's going to be hilarious.
Yes, it is.
All right, guys. Do your own research. When you do, you'll never again believe what you've been taught. Till next time, this has been Jeranism. Later, haters.
Oh.
Yeah. Yeah. It was nice just hanging out. Now go and hit the bell. Share it with the homies so that they could grow as well. They missing out. Jaren leaves no doubt. If you know what we bout, it's never for the cloud, don't fuck around. Hey, not for the clout, that's too cap, we calling them out. Balls get flat when you cover the route. Jeranism all in your mouth. Truth gets lost like all on the couch, but it's time to get up and make them get out. Uncover the route. Jeranism, we are the crown. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI. All just scientism lies.
Who this be? What he about? You stay spinning, he stand out. About flat earth, it's flat out. He's still standing when you passed out. Globers pound, scream and shout. He can turn you inside out. Yeah, surface deep, he's felt throughout. And he stay grounded, you spaced out.
We gotta run nowhere when we come fact check your facts and match your data. Concept is too abstract, what matters? Try to tune in, but the note get flatter. Tell me I'm flattered. Flatter than pancake batter, now we landed. Jeranism, I'm your captain. Speaking, telecasting worldwide. Check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide. Check the globe is falsified. Space is spinning DFI, all just scientism lies. You know equations to the things you make the symbols for, but ain't really explaining what the symbols for. They try to teach you things against the things we taught before. No point in arguing now, they don't wanna talk no more. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Thanks to the east side, thanks to the west side, thanks to the north side, way down to the south side. Thanks to the east side, thanks to the west side, big ups to the north side, way down to the south side. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies.
I'm here with Alex Stein. Alex, what do you think of people who don't join my VIP club?
Guys, join the VIP club, $15. If you can't afford that, you need to stop watching YouTube and go freaking get a